Hey, how's it going? It's good to see you. Glad you came. Let's talk about exploring angle pairs. Essentially, what you need to understand is that there are special angle pairs that can help you identify geometric relationships. You can use these angle pairs to find angle measures. Look over here. Look at these guys. Angle 1 and angle 2. How are these guys related? Angle 3 and angle 4. How are these guys related? These are called adjacent angles. They're two coplanar angles with a common side, a common vertex, and no common interior points. Hey, these look like the ones we used when we did the segment addition postulate. And that's exactly what they are. Let's see, how are these ones related? Angle 1 and angle 2, like straight across from each other. Angle 3 and angle 4, like straight across from each other. You might even say that angle 3 is like vertically across from angle 4. You might say that. In fact, you probably should say that. These are called vertical angles. Two angles whose sides are opposite rays. Another way to say that is the angles made by two lines that are right across from each other. Boom! Let's see. Angle 1 and angle 2. Angle A and angle B. How are these angle pairs related? No, they're not cousins. They're complementary angles. Complementary angles are angles whose measures add up to 90. Each angle is called the complement of the other. So angle 1 is the complement of angle 2 because they add up to 90 degrees. Angle A is the complement of angle B because, yes, they add up to 90 degrees. So what about angle 3 and angle 4? What do they have in common? What about angle B and angle C? How are they related? Yes, they actually are cousins. But more importantly, they're supplementary angles. Supplementary angles are two angles whose measures add up to 180 degrees, and each angle is called the supplement of the other. Angle 3 is the supplement of angle 4 because they add up to 180 degrees. So tell me, is this statement true? Is angle BFD and CFD, wait, are those adjacent angles? BFD and CFD? Let's see, a definition of adjacent angles. It says common side, common vertex, no common interior points. So they have a common side, FD. They have a common vertex, F. But do they have no common interior points? I would say nay. Every point in here, every point in the interior of CFD is also in the interior of BFD. So I'm going to have to say no. These are not adjacent angles because this angle is inside the interior of BFD. Those are called common interior points. And adjacent angles just don't have any of those. True or false? Angle AFB and angle EFD are vertical angles. AFB and EFD. I'm going to say no. AFB and EFD. The problem here is that ray FB is not an opposite ray of FE. See, not opposite rays at all. We're not having two lines intersect here. What about C? Is AFE and BFC complementary? AFE and BFC. Complementary means add up to 90. So 62 plus 28 is 90, so yes. Alright, pause, see if you can get these. So our AFE and CFD vertical angles, AFE and CFD are vertical angles because they're made by two lines that intersect right here. So this right here would be 62 degrees. Oh, we didn't say yet that vertical angles are congruent, but we will. What about angle BFC and DFE? Are they supplementary? BFC is 28 degrees and DFE is 118 degrees. When we add those together, are we going to get 180? No. So this is false. This one was true. Alright, angle BFD and AFB. So BFD and AFB. Here's AFB, here's BFD. They share a vertex, they share a common side, and they share no interior points. So that is true. Here's a little concept summary for you. So here are some things that you can conclude from an unmarked diagram. You can conclude that angles are adjacent. You can see if they're sharing a common side, if they're sharing a vertex, and if they don't have any common interior points. You can also conclude that an angle is supplementary. If it's a straight angle, if you've got a straight angle here and another angle there, you can say that angle 1 and angle 2 are complementary because this is a straight line. You can see that in an unmarked diagram. And vertical angles you can see in an unmarked diagram too, because you can tell when two lines are intersecting. What you can't say is that two angles are congruent. If you see angle A and angle B like this, and they're not marked, they don't have little arc here saying they're congruent, you can't just say, hey, they look the same, they must be congruent. Can't do it. Can't do it. Unless they have little things like this, then now we can say they're congruent. But without those, I can't do it. What if I see an angle like this? I have to be able to say angle B is a right angle, right? Nope. Only if it has one of these. That's a marking. But without that, I have no guarantee that this is 90 degrees, just because it looks close to 90 degrees. And on that same token, I can't say, hey look, angle 1 and 2 are complementary. Can't do it because I don't know for sure that this is 90 degrees. So what can we conclude from the information in this diagram? Well, let's look at it. We can conclude that angles 3 and 5 are vertical angles. We can conclude that angles 1 and 2 are congruent because they have little marks. We can conclude, let's see, this is a straight line, so we can say that angle 4 and angle 5 are supplementary and that they're adjacent. We can say that 3 and 4 are supplementary and adjacent. We can say that angles 1 and 2 are adjacent. So let's see what we got here. Angle 1 is congruent to angle 2 by these markings. Angles 3 and 5 are vertical angles because they're made by two lines intersecting and they're straight across from each other. All these adjacent angles. 1 and 2 are adjacent. 2 and 3 are adjacent. 3 and 4 are adjacent. 4 and 5 are adjacent. 5 and 1 are adjacent. 3 and 4 and 4 and 5 are adjacent supplementary angles. Fair enough. Alright, so number 2, you can pause if you want to do this on your own. Well, not if you want to do, you have to. You have to pause and do this on your own and then push play to see the answers. I hope you're participating correctly. If not, that's cheating. And you'll feel guilty about it one day. Okay, so A, can we make this conclusion? Segment TW is congruent to segment WV. The answer is yes, because we have these little congruence hash marks. How about B? Segment PW is congruent to segment WQ. Well, they look congruent, but can I conclude that? For sure, no, because I don't have any markings telling me that. I don't have any other information telling me that. Angle TWQ is a right angle. Do I have any markings telling me it's a right angle? No. Cannot conclude that. Segment TV bisects segment PQ. Can I conclude that? That TV bisects PQ? The answer is no. Because I don't know that PQ is divided into two congruent segments. I can say the other way. I can say that segment PQ bisects segment TV because TV is bisected into two congruent segments, TW and WV. The linear pair postulate. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. Basically, a linear pair is adjacent angles that form a straight angle. A linear pair is adjacent angles that add up to 100 degrees. So if two angles form a linear pair, then they are supplementary. That is the postulate. All right, angle KPL and angle JPL are a linear pair. The measure of angle KPL is 2x plus 24, and the measure of angle JPL is 4x plus 36. What are the measures of KPL and JPL? We know that they're supplementary because they're a linear pair. We need to find their measures. So we can draw a diagram, and then we can use the definition of supplementary angles. Linear pair is a line and then two angles that are adjacent. So we know that KPL and JPL are adjacent. That means that 2x plus 24 plus 4x plus 36 is going to equal 180 degrees. So then we just use some magic algebra to solve this equation. And we get x equals 20. Now all we need to do is plug that 20 into those expressions. So 2 times 20 is 40. 40 plus 24 is 64. So KPL is 64 degrees. And then JPL is 4x plus 36. Substitute the 20. 80 plus 36 is 116. So this angle is 116 degrees. Let's see, how could you check your results in problem 3? Well, I could make sure that these two add up to 180, right? And they do. ADB and BDC are a linear pair. So I'm going to have A over here, D right here, C over here, A, D, B somewhere over here. The measure of ADB is 3x plus 14, and the measure of BDC is 5x minus 2. I know they add up to 180. Right over here, I'll write 3x plus 14 plus 5x minus 2 equals 180 degrees. Combine like terms. 3x plus 5x is 8x plus 14 minus 2 is 12 equals 180. Subtract 12 from each side. 8x equals 168. Divide both sides by 8. Just double check. 180 minus 12 is 168. 168 divided by 8 is 21. So x equals 21. Are we done? Negative. We want to find the measures of these angles. Measure of angle ADB is 3x plus 14. So 3 times 21 plus 14. 3 times 21 is 63. Plus 14 is not 882. Let's try that again. 3 times 21 is 63. Plus 14 is 77. Measure of BDC is 5x minus 2. So that's 5 times 21 minus 2. 5 times 21 is 105 minus 2 is 103. And do these two add up to 180? You betcha. An angle bisector is a ray that divides an angle into two congruent angles. Two congruent adjacent angles, by the way. Within the ray, a segment with the same endpoint is also an angle bisector. So segment AY, you could call that the angle bisector, or ray AY, you could call that the angle bisector. Okay. Multiple choice. AC bisects angle DAB. If measure of DAC equals 58, what is the measure of DAB? Well, I'm going to draw angle DAB. Remember, the middle letter has to be the vertex. AC bisects it. It's a ray AC. DAC is 58 degrees. What is the measure of angle DAB? Well, these are congruent. It's bisected, so this is also 58 degrees. Then I add those together, and I get 116 degrees. If you like it typed, boom, 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 and boom. Okay, number 4. Ray KM bisects angle JKL. Pause it, see if you can figure it out. Here we go. Angle JKL. And then ray KM bisects it. JKL is 72. So the whole big dude is 72. Well, we just need to divide that by 2 to figure out what each one of these is. 72 divided by 2 is 36. So this guy is 36, and this guy is 36. And those two add up to JKL, which is 72. So what's the measure of JKM? 36 degrees. I hope you enjoyed yourself. Work on practice 1.5. Make sure you do as many of those problems as you can until you understand what you're doing and you feel super confident. Then do the formal write-up, and then submit it, and I'll get back to you. Make sure you wait for me to get back to you before you jump on that quiz. Bye.